Question 5. They say Richard takes a flight between Aston and Beijing every day, and the probability of arriving early is 0.15, on time is 0.55, and being late is 0.33. The sum is 1. Yeah? They're saying find the probability that each of the 3 randomly chosen days Richard's flight does not arrive late. All 3 days it is either on time or early. So it will be on time or early, right? On time or early. So what is the probability of on time? On time is 0.55 and early is 0.15. That makes it 0.7. We could have also gotten 0.7 by subtracting 0.3 from 1. That is the one we want. So every day, first day it is on time or early, second day again on time or early, and third day it is again on time or early, and if we multiply them we will get 0.34. B part. They say that find the probability that 9 randomly chosen days Richard's flight arrives early at least 3 times, which means they're asking that it will be at least 3 times, right? So it will be 3 times or 4 times or 5 times up to 9 times. This will be a tedious job, long. So how about this? In place of this we write 1 minus probability that it does not arrive early any day, or it arrives early on 1 day or 2 days. This will be better, right? And for doing that, binomial probability will be the best. Why? There are 4 conditions. There should be a success or failure, and we know the probability of success in this case is 0.15 and probability of failure is 0.85. That's done. Probability should remain same all days. That's what they're saying. It is the same for all days, right? Third condition, 1 day and second days should be independent of each other. Yes, they are independent. And fourth, there are a limited number of days, which is 9. That's fine. So we can use it. Binomial probability. So 1 minus, and for P0 will be 9C0. Success is 0. And failure is all 9. For 9C1, success is 1, failure 8. For 9C2, 2 successes but 7 failures. And this is what we'll put in our calculator, and that will give us our answer, which comes out to be 0.14. In C part, now they are saying that 60 days are chosen at random. Use the approximation and approximation to find the probability that Richard's flight arrives early at least 12 times. 60 is a very big number, 12 is also big, and at least 12, that means it's a long range. So binomial probability will not be a good choice here. So we should use normal distribution approximation. For that we have to test first that NP is greater than 5. So N is 60 and success probability is 0.15, which will be 9, which is greater than 5. 9 is greater than 5. NQ, obviously because Q is 0.85, definitely it is also going to be greater than 5. So we can use normal distribution here in this. So this is normal distribution. Mean will be NP, which is 9. We already got it. Okay, and then we need a standard deviation, which will be square root of N, P, and Q, which will be N is 60, 0.15, and 0.85 square root, which is approximately 2.77. Now this is 9. Yeah. So we want that it is early rather greater than 12. So we want the probability for actually this area, which includes 12. Right? So at least 12 means 12 is included, right? That means when we'll get this area, this will not have 12. So we need to know a z-score for x is less than 12. So that will be 12 minus 9 over 2.77, which is 1.083. Now the probability that x is less than 12 is equal to the probability related to this z-score. For that we will go to a table. Here we can see 1.0 is here, 1.08 is 8599 and 3 is 7. So it will be 8606. So 0.8606. But if you look at the question, it was find the probability that Richard's flight is early at least 12 times. That means we want this area, right? So we'll subtract this from 1 and we'll get that, because that will include 12. And that answer will be 0.1394.